Okay, so here is today's headless chemistry video. So right here with my molecular modeling kit, I have built glucose. And you might not immediately be able to tell this is glucose because you're used to looking at glucose in Fischer or in Haworth projection, and this is good old molecular model projection. But I'm going to try and convince you that this is in fact glucose. And hopefully in doing so, I'll sort of illustrate how weird Fischer projection is. So first of all, it doesn't take a rocket scientist to count and say, yes, indeed, Mazer, you have 6 black balls there. 1, 2, 3, 4, 5, 6. This is a 6 carbon thing because carbon is always black in molecular modeling. Hydrogen's always white and oxygen is always red. It gets its red designation because it is the most electronegative thing you find in most biological molecules. And at one end, we have a double bonded oxygen. See that double bonded oxygen? So this is an aldehyde because that's a terminal carbon with that double bonded oxygen. So 6 carbons and an aldehyde. You see lots of little OH groups here. So this is definitely a polyhydroxyaldehyde with 6 carbons. By definition, this is a hexose sugar. But is it glucose? Well, you know that when you're looking at chiral carbons, and glucose has 4 of them, you have to look so that the up and down bonds, the vertical bonds, are going back into the page away from you, and the horizontal bonds are coming out towards you. So let's take this first chiral carbon, carbon number 2. And remember, glucose is right, left, right, right. So let's see if I followed that pattern correctly. First carbon, not chiral because it's got that double bonded O. So we look at the second carbon, and I've got it right now. So these 2 horizontal bonds are coming out towards you, see? And the other 2 are going back away from you. And the first OH in that configuration is on the right-hand side. Excellent. So now we've done carbon number 1, not chiral. Carbon number 2, check. Carbon number 3. So we have to rotate it so that once again, when we're looking at carbon number 3, the up and down bonds are going back away from you, and the side-to-side bonds are coming out towards you. See? And once again, the OH is on the correct side. Right, left, right, right for glucose. Now we advance to carbon number 4. And once again, we have to rotate this thing so that our up and down bonds are going back away from us and our side-to-side bonds are coming towards us. This one is on the right as it should be. Rotate to the next one, orient it so the up and down bonds are going away, the side-to-side bonds are coming towards you, and in fact, we're on the right. So that's my last chiral carbon. My final carbon down here is CH2OH. So this is in fact glucose. But in order to get it into Fischer projection, I basically had to curl it into a circle. Because every time I looked at a chiral carbon, the up and down bonds had to be going away from me. So I only looked at one carbon at a time, but every time I did, the up and down bonds were going away from me. This is not the normal configuration of straight chain glucose. It was much more accurate when I started. In fact, this looks like a glucose that's about to cyclize because look at how close that DL oxygen is to that carbon-denuded carbonyl carbon. So it looks like it's about to cyclize. But that's what Fischer projection does. It is not a normal, stable configuration for a molecule. It's just a very convenient way to draw it.